Okay, today we're going to talk specifically about prototypes. Um, so oftentimes so let's talk about the why. Um, Oftentimes prototypes are important because the solution to a problem can be expensive. And that can be expensive in terms of dollars. It can be expensive in terms of time. And it can be expensive in terms of risk. All of these can be things that are expensive. So a prototype is ultimately a type of model. So earlier this year we had a whole unit on models. So a model could be anything from like a computer model to an equation to a physical model to a full size working whatever. But the model has to be working in such a way that it can be tested and measured as part of that test. It doesn't need to be a complete design. It should use minimal resources, but it should be able to give us an accurate test. So it has to be testable, right? Shouldn't be a full-on solution because a full-on solution is going to be expensive with money, time, and risk, but it has to be testable. And in order to be testable, you have to be able to accurately measure something using it. All right, so let's talk about the elements of how do you test a prototype. Okay, so the first thing is that we have to have an objective, measurable goal. Okay, so in this particular test of our prototype, we have to have an objective, measurable goal. This should be set down in writing before you start testing. The goal should be written as a pass-fail statement. So an example of something like this is like if you were to try to prototype a new battery. So you might say something like, if the prototype exceeds being able to output 3.5 amps for 32 hours, then the prototype has passed the goal. So it's objective and it's measurable. We pass if we exceed, okay, so it could be some statement of exceeding or does not exceed. There's a measurement here. We're outputting 3.5 amps for 32 hours. And that's the criteria that we need for a pass. If we've got that, then we have passed the goal. These goals should be aligned to the solution, how we defined a solution for solving the problem earlier in the design process. So that's one of the big things. You should have to have an objective, measurable goal. You also want to have a controlled environment. So each time you test your prototype, you want to test it in as close to the same environment as you had in the previous time. The only thing that should be changing is the prototype itself. And that way we know that the measurements that we're taking are changing as a result of the changes in the prototype and not as a result of changes in the environment. We want to have calibrated and accurate tools for measurement. So ideally, when you're testing a prototype, each time that you test the prototype, you should use the same set of tools. That way we know that the results and the measurements are changing as a result of the prototype changing, not as a result of moving from one tool to another. If the tool can be calibrated, it should be calibrated before each and every test. And we want to make sure that those tools are accurate as they can be. So calibrated and accurate tools for measurement. In each test, we want to have multiple trials. Okay, so we want to make sure that there's not something about a particular trial that caused an odd result. So when you test your prototype, you should try to test it multiple times, and you should decide ahead of time how you're going to aggregate that information. Are you going to take the mean of the measurements? Are you going to take the median of the measurements? Are you going to take the percentage of trials that are successful? This way you're using the exact same data point each time that you conduct a trial. And finally, we have to record the results. So you want to record all of the data from all of the trials. So you want to record all measurements. But you also want to record any other observations that are non-measurement observations that you have during the testing. So the idea here is the measurements will tell you whether or not you are moving closer or further from solving your problem. The observations will allow you to make a determination as to why those measurements are changing, so they can start informing your redesign process. So remember, prototyping and testing prototyping sits between research, or between choosing a solution rather, and redesign. So once you've chosen the solution, you should have a method for testing it, or at least testing a model of it. And then you use those tests in order to inform the redesign process on the other side. All right, so 5 major things that we want to make sure are happening in prototype testing: an objective measurable goal, controlled environments, calibrated and accurate tools for measurement, the usage of multiple trials, and recording all measurements and observations of non-measurement realities in the testing process. All right, so there you go.